Welcome to the lecture series Programming in C. In this module of this series, we are going to learn about pointers and functions. This module covers how pointers can be used as function arguments, how pointers can point to functions and how it can return values, how pointer arrays are going to be accessed and how we can make use of pointers to access each and every element of an array, and examples relevant to these concepts. First of all, we should learn what it means by function pointer. We have learnt pointers as a concept that the pointers variable can have the address of another variable and it can point to the address, and we can dereference the pointer by accessing its value. We have also learned about functions, that functions are going to help us create subroutines or subtasks for which we are supposed to create our own user defined function with the syntax of having data type, user defined function name and the list of arguments. The data type is going to be the data type of the return value from the function. So, whenever we have function, the function call statement is required from the function which we are trying to invoke the function, and the call will be sent to the function, and after executing all the statements in the function pointer or function call control will be given back to the calling function. So, this is what is the basic concept of using functions. So, we have learnt various types of functions like call by value, call by reference methods. So, this session is completely going to be on the combination of the concept of functions along with pointers. So, C language makes extensive use of pointers that we have already seen. They can be used to provide indirect references to primitive data types like creating dynamic sized arrays, to create instances of structures and to manipulate the string type data. Pointers are also used to create references to functions. So, in other words, a function pointer is a variable that contains the address of a function. So, it is a very interesting concept in C language that we can have the address of the function itself to be stored in a variable, right. So, the simple way of creating the function pointer is, with the function name, generally we will be using only the user defined function name. Along with the function name, we are supposed to add the symbol asterisk. So, this is the general syntax of a function will be the data type. So, I use the data type as int, the function name which is I am using as foo, and the list of arguments we can make use this way. Right. This is a general function declaration statement. Here I am going to just add one asterisk symbol to make it as a function pointer. Okay. So, if I am adding the asterisk symbol, this declares that it is going to be a function pointer after declaring it to be with the asterisk. Okay. Right. What is the use of going for function as pointers? So, memory stores the function code. The address or start of a function is referred to as the function pointer, and the function pointers do not allocate or deallocate memory. They are different from other pointers. They do not do anything. They will just be pointing to the address from where the function starts or begins. It is possible to pass function pointers as arguments to other functions. So, it can even return the pointers as return values. So, it is all possible with the pointers. We will see one by one. So, function pointer declaration. Unlike a function declaration, a function pointer declaration wraps the function name in parenthesis and precedes it with an asterisk, right. So, this is what is a simple function declaration statement. This we have got used to in the previous sessions, that the return type will be the int data type, function is a user defined name, and x and y are the list of arguments that we pass to the function. right. This is a usual function declaration statement we have already learned. Now, that we are making as a function pointer. How do we do it? Just we are making two things to be done. One will be the addition of the symbol asterisk with the user defined function name, and the second thing is addition of or making it wrapped inside the parenthesis. Okay, so these are the two changes that we are supposed to do in case if we want to declare the function as a pointer. Okay, so let us take an example. We will declare one function as a user defined function. Okay, one thing that you can see here is one of the argument of the function I am passing as pointer, right. So, what we do inside the function, we are declaring a local variable named x with the value 200, and we are declaring a pointer type variable, and we are assigning the value 200 to it and the return statement, right. So, what here we are doing, we are trying to make the value of x as well as the PTR's value to be the same, right. Now, we have a main function. In the main function, what we do, we are declaring two integer type variable p and q with the values 10 and 20. We are also displaying its values, right. Now, we are invoking the function test. Okay. So, this is also called function call statement, right. So, here the signature of the function call statement should match with that of the function prototype. Function prototype says that the first argument is integer, the second argument is the pointer. The same way, I should pass an integer and a pointer as the argument to the test function, right. So, after function call statement, the call will be transferred to this function and it executes these statements. When it encounters a return statement, the function control will be given to the next statement after the function call statement. Okay, so this is the usual procedure of invoking a function, right. So, after the function call, we are also displaying the value of p and q, right. Now, what happens, how it executes, let us learn. So, in this code, p remains at 10 as there is no return value from the function test, right. The function does not return any value from this. So, the value of p is not altered. So, it remains the same as 10. However, if you see the value of q, that changes from 20 to 200. The very basic reason is that is passed as a pointer. Since it is passed as a pointer, the original value that the pointer points to will also be modified if the pointer value is modified. So, here we are modifying the pointer value to be 200. So, what happens? Even the original value of q will be modified. So, that is the reason that we will be getting the output of p and q before the function call to be 10 and 20, after the function call to be 10 and 200. So, when we change the value of the pointer, it will automatically get reflected in the main function also. This is one important concept that we are supposed to learn. Okay. So, what happens? Let us learn with the schematic figure. So, here in the main function, we have the variables q value, its value to be 20, and the address of q it is 65 fe1c, right. So, when there is a function called test, we are passing the pointer as the parameter or the argument, right. We are modifying the value stored in that particular address to be 200. Okay. In step 2, what happens? There is a variable q whose value is 200. The address of q is 65 fe1c, which is actually pointed by the ampersand q, that is address of q. It is what is stored in the pointer variable. So, when we are trying to make changes in the pointer variable, automatically we can see that the value of q is also getting modified. So, even after the function call, the modified value will be there in the original value. The original value and the address, the pointer value will be pointing to the same location, and whatever the changes that we do in the location will even be reflected in the original value. So, the output can be initially before calling the test function it will be 10 and 20. After invoking the test function it will be 10 and 200 because the value it's getting modified. We can also pass pointers as function arguments. We have already seen one example of passing pointers as function arguments, but still we will learn in depth about passing pointers as function arguments. Okay. Let us take an example of the swapping the values of two variables. Okay. Let us name the variables as x and y, right. So, the values which are there in x and y are to be swapped, right. So, let us assume that the value of x is 10 and the value of y is 20. So, after the execution of the program, the value of x should be made 20 and y should be made 10, right. So, when we want to do this swapping, supposing when I am trying to store the value of y to x, already what is the value that is there in x would be deleted, right, or would be overwritten. So, the value of x already it was 10. Now, we are trying to store the value of y onto x which is 20. What would happen to the value of value which is already there in x, which would be overwritten, which would be deleted. So, if that is deleted, then we will not be able to make the copy of its value to x. Y equal to x, when I say x is already not there. So, we will not be able to do this swapping directly with only two variables. So, what we need? We need a third variable as a temporary variable. So, which will have the copy of one value before swapping, and we can do swapping, then after swapping we can retain the value in that way from that variable. Say let us go to that sequence of operation. Let me have a temporary value, temporary variable which stores a value of x, the previous value of x. Now I am storing the value of y onto x, right. So, x was already 10, so temp will take the value 10. Now y was 20, so x now takes a value 20, and we can see here that y equal to, now I can copy the value which is there in temp, right. Now y can take the value 10. So, at the end of the execution we can see that x now takes a value 20 and y takes a value 10. So, there is a swapping being done with a third variable introduced, right. Now, if we are using pointers without using even a temporary variable, we can make this swapping done, okay. So, how that could be done? We can pass the function arguments, we can pass the pointers as function arguments. So, what here we can see? We are passing two pointers as arguments to the swap function, right. Since both are pointers, seriously what we are here, we are doing ampersand star x equal to star x plus star y. It means that the value which is stored, which is dereferenced by x, which is dereferenced by y, those two values are added and we are storing it in x, and star y equal to star x minus star y and star x equal to star x minus star y. So, by doing so, we will be able to swap the values of x and y, right. So, for swapping the values of two variables, we will be able to use a pointer as function argument, and while calling the function you can see a interesting thing that instead of values we are going to pass the address of A and address of B. So, once the address is given to the swap function, that will be able to reallocate the values, and the swapping can be done just with these two parameters itself, with these two variables itself, right. So, let us work out with one more example of swapping two values, right. So, here what we do, here we are introducing a temporary variable and we are having the location of one pointer to be stored in the temporary value or variable, and then we do the swapping of the pointers, and we are making the temporary value to be pointed to be stored in the another pointer variable, right. So, let us take an example of having values of x and y to be 45 and 65. We display the value before swapping, and for the swap function, for calling the swap function, I pass the address of x and y. So, those address of x and y will be received by the pointer variables p and q. So, after representing the p and q, we do the swapping with the address values, not with the values. So, here we can see that asterisk p equal to asterisk q, in the sense that whatever the value which is stored in q will be swapped with value stored in p. Okay. So, after swapping, we can see that the value of x now has become 65 and the value of y now become as 45, right. Okay. What is the name given to these arguments when it is passed as pointer to the function? We call it as a reference parameter. So, to make changes to a variable that exists after a function ends, we pass the address of the variable to the function, which is actually called a reference pointer, right. Then we use indirection operator inside the function to change the value of the parameter which it points to, right. So, simply what we can see, we can take a function change variable which takes a pointer as the parameter or argument, right. So, we are just modifying the value stored in that pointer variable, we are adding value 10 to it, right. We are declaring a variable of variable x with the value 5.0, and we are passing the address of x to this function. So, what happens actually, since we are passing the address of x, x already has a value 5.0. We are passing the address of x to the function. In the function, what we do, we are dereferencing the pointer variable and we are adding its value with 10. So, what happens, 5 will be 5.0 will be dereferenced and we are adding the value 10.0 with that value, which will be updated onto the pointer or onto the particular address. So, here we can see that the value is updated even to the particular pointer. So, if we display the value now, we will be getting the updated value as 15.0, right. Now, as of now we have learnt how to pass a pointer as a function argument and how to do the swapping process between two pointers in the function call or in the function statement. Now, we will learn about return values, how to return a pointer. Okay. So, why or in which particular scenario we may require returning a pointer is that we will be executing the function, and after the function statement, if we want to return the pointer as an argument, pointer as a value, then we may require returning pointers, right. Then how to declare the return pointer as float asterisk, here I am giving the asterisk symbol to mention the function name, and we are passing the float type array and an integer n, right. So, here you can see that I am declaring a float type pointer called asterisk the max, which is going to pass to the first element of the array. Then I am executing a loop to find what is the maximum value stored in that array. So, if a of I is greater than the max, then the max will be the address pointing to that particular location. So, if we run that loop, that we will be returning the maximum value from that loop. Okay. So, we are returning the max, right. So, the max is what? The max is a pointer. So, we have declared the max as pointer and we are returning the max. Then it means that we are returning a pointer from the function, right. So, how we can implement it using the main function? We are declaring, we are supposed to declare a floating point pointer, because the value which is returned from the function is going to be a floating point pointer, right. So, what I can do for the function call statement, I should have the return data type should be of floating pointer. So, that is what here we are defining. Either we can do that way, after getting the max A pointer, and from the function we will be able to do arithmetic operations as usual with the pointer. So, here we are trying to increment the pointer's value by 1, right. So, there is one more example to find the maximum of two values using pointers. Okay. So, if we are passing on two pointers and if we are trying to find the maximum of those two pointers, the return value will also be a pointer, in the sense that which is the value which is having the maximum value, the address which points to the maximum value will have to be returned as the return value, right. So, here we can see we are defining a function with max as the function name and two pointers A and B. We are comparing the values of those two pointers and we are returning the pointer. If we are returning an integer type pointer, we have to make the function definition to have the return value as int asterisk. In this case, the first case we had it as float asterisk because it returned floating point pointer, whereas this returns integer pointer, so it has to be made as an integer pointer int asterisk, right. In the main function, I declare an x value, I declare a y type y value variable, integer type variable, and an integer pointer. Okay. So, what we are doing now? We are calling the max function, we are passing the two pointers as arguments ampersand x and ampersand y. We compare the values of those two addresses. Actually, ampersand x points to 105 and ampersand y points to 102, right. So, these two values are compared, which is the value which is having the maximum value, the address of that value will be returned as the return value. So, the address where 105 is stored will be returned. So, that would be received by the pointer variable PTR. So, when we want to display the value stored in PTR, we have to dereference it using asterisk symbol, right. Hope now you would have understood how to return the pointer as a return value. Then we will learn about using pointers for arrays. So, if an array stores pointers of some variables, then it is called a pointer array. Okay. So, what here we are doing? We are having a character array as a pointer. Here we are having integer array is having a pointer symbol. It means that it stores pointers to undefined int values. Similarly, float asterisk asterisk age, it is also a pointer array which is pointing to undefined float values. So, the first case the pointer is pointing to characters or of having 100 elements, or you can say that simply it stores pointers to 100 strings. Then mark is an array, again it is an integer type pointer array which points to integer values. Then the third category is float type pointer array which points to float values, right. Right. Now, let us learn how pointers are handled with 2D or two-dimensional arrays. We have already created a one-dimensional array of characters to represent a string. If you want a list of strings, then we need to look for two-dimensional character array, right. So, two-dimensional character array, how it can create a list of strings. Say for example, the first string Kolkata, Mumbai, Hyderabad, Chennai, Bengaluru. So, these are all going to be the city names which are going to be represented in the form of two-dimensional arrays, right. So, we will create a pointer named city, or which will be pointing to the two-dimensional array. So, how it points to the two-dimensional array? The first location of the first string will be having an address. So, that address will be stored in the array pointer city. So, this is what is the example. We are creating a city of two-dimensional array, 20 and 15 elements, it is 20 rows and 15 columns each, and we create now an array. which is going to be a pointer array, right. So, the character city equal to we will be able to create a n number of strings and we can make it point to the pointer array, right. I am using the format string percentage %s and we can display simply city of I, or we can even make use of the pointer element, pointer I mean the address of city, and then plus I will indicate the indices, what index you want to display. So, the index, the next strings will be accessed through the index I. Pointer to functions, as we have already seen, if we are having a pointer to function, we have to create the function name with the asterisk symbol and it has to be enclosed within parenthesis, right. So, in case if you want to create a pointer to a function, the alternate way of creating the pointer to function will be the return type and the function name with the pointer symbol and the list of arguments ending with semicolon, or otherwise we can create data type, function name, type 1 argument, type 2 argument. Each argument's data type can be individually given and it can be given even with the argument name. So, these are the two ways that we can declare pointer to functions, right. So, this is a simple example of creating pointer to functions. So, I am what are the two steps I am supposed to do if I am creating a pointer to a function. I need to use a asterisk symbol and I have to enclose a function name within parenthesis. So, those two things I have done, and the first case is without any list of arguments. The second case is we are having an add function with two double arguments, right. So, we are now be able to make the address of a add function to be assigned to the pointer, okay. So, we have already created p as the pointer variable and we can just make the address of add to point to the pointer function. So, here we can say instead of invoking the function as add a comma b, I can simply make it as asterisk p a comma b. So, wherever there is a symbol add or the function name add, we can replace it with our pointer name, because we have assigned the pointer, the function add to the pointer p. We have assigned the function name add to the pointer p. So, then thereby wherever you want to add, use a function name add, instead we can make use of its address as asterisk p. So, this is equivalent to add a comma b. And passing functions to other functions. A pointer to a function, say a guest function, can be passed to another function, say a host function, as argument. This allows a guest function to be transferred to host as though the guest function were a variable. So, successive calls to the host function can pass different pointers to the host. When a host function accepts the name of the guest function as an argument, the formal argument declaration must identify that argument as a pointer to the guest function. So, this is the example we can see for passing functions to other functions. So, here we are defining the guest function as with the data type and the guest function name with all arguments list. We can also define the host function with the same way that data type, host function name, but here there is a difference that here we are supposed to define a pointer to guest function. So, this is a pointer to guest function we are defining. So, then thereby we can pass the function name itself as an argument, or the address which the particular function points to as an argument to the function. Thereby the function will be able to even get other functions name or other functions location through the pointer. So, this is an example of passing functions to other functions. So, here we can see that I am just giving one additional notation of declaring the host function with the pointer, and we can declare the guest functions as function 1, function 2 with the same signature. So, what I do here in the main function, I am invoking the function 1, okay, using function 1 name, using function 2 name. So, this is an interesting thing that the function name itself can be passed as an argument, because we are making the host function to accept the function name of the guest function. Accordingly, we will be able to execute that particular function. So here we can see that this is the template of the process function or the guest function or the host function, which is going to accept the guest function, right. So the guest function will be function 1 or function 2. So here we can see the return statement is going to be simply integer for both. So here we can see that C equal to the function pointer along with the argument list. Okay. So whatever be the condition which suits either function 1 or function 2, we can execute. Then pointers to functions. So this is again one more example where we can make use of the concept of pointers to function. This already we have gone through. We are now looking at as an complete example. So this function, this program is to read the numbers to be sorted and read the string data to be sorted. We are comparing two numbers to compare, a comparison of two strings, and then we are trying to swap the values. So in the main function, what we do, we are trying to read the integer values as well as we are trying to read the strings. We are going to perform the sorting function or arranging the values in order, either ascending order or descending order, but the data type varies. The data type for the first function, it is going to be integer, for the second function it is going to be string. But what we are going to pass as a parameter to these functions will be the function name. So both the function name sort is going to be the same for both integer as well as string, whereas we are going to pass the pointer to the functions. So while passing the pointer to the function, we are just going to pass the array or the location of that function. By doing so, we will be able to differentiate these two functions even though the function name is going to be the same. Yeah, summarizing on this particular session, we have learned about passing pointers as function arguments, and by doing so we can avoid using third variable or a temporary variable while swapping, and we have seen the examples related to it. And we have also learnt about pointers and functions, how to make use of pointer to functions and how to have the pointers as return values. Also we have learnt the concept of having pointer array with respect to integer, floating point value as well as the character. Also we have learnt on two-dimensional arrays with the help of string representation and its examples. So thank you so much for listening this session. Thank you.